Great to see you all. Thank you for coming. And my name is Steve, and I'm going to be talking to you about this JavaScript library called Knockout.js. And this is a project that I started, about 3 years ago or something now, and it's gone really well, better than I thought it would do. It's gone from strength to strength, and it's got many contributors now. Hopefully, I've got all the relevant copyrights and stuff, and it's in use in hundreds of production applications. So hopefully this is going to be of relevance to many of you in your actual work. So how many of you have used this? Hands up. All right, okay, so about maybe 10% or something. That's good. All right, so let's talk about what problem this is intended to solve. Now, think back to the last time that you started a new software project. Hopefully, being a respectable developer, you said, this project is going to be really tidily organized, and all the different parts of the software are going to neatly fit together like some kind of elegant tapestry of software beauty. All the different parts will be lined up, and it will be aesthetically lovely, and it will be clean. And sometimes it does work like that. But sometimes, if your architecture is not all that well organized from the beginning, then instead of feeling like this elegant professional weaving process, it starts to feel more like a bit of a battle between you and all the different threads of your system, and you're getting all sort of wound up and tangled up in them. And then after you've been tangled up and it's stuck in your teeth and you're coughing up furballs of different open source libraries, you have to stop and take a step back and consider, what is going on with your life? And does this make sense? How did you get into this situation? And how can you get back to a more organized position? So this is where libraries like Knockout come in. Knockout is, as I said, a JavaScript library. It's on GitHub. It's MIT licensed, like basically all JavaScript libraries. And it's there to help you write your code in a Model-View-ViewModel style. And that pattern is very much like Model-View Controller, Model-View Presenter, whatever you want to think of. And in Knockout's world, what we mean by that is that your model is some data that you've got on your server, in a database probably, and that gets persisted somehow. But Knockout doesn't care at all about how that's going to work. You can write any server-side technology. Knockout is interested in what you've got on the client. And so Knockout helps you to build a view model, and that is an object-oriented representation of your user interface. So let's say you've got a text box, then there's probably a property that corresponds to the value of it. Or if you've got a button, then there's probably some kind of function that corresponds to what happens when the user clicks that button. So it's just plain code. It's got nothing to do with HTML or CSS or whatever, so it's very easy to unit test. It's nice and abstract. But of course, the user has to be able to see something, so you're going to have some HTML, and that's your view. And Knockout is concerned with helping you keep your view model and your view in sync. So when your view model changes, the view changes, and vice versa. And so that's going to hopefully give you a much more tidy way of organizing your code. So many of you may be thinking, so what? Because you know what, there's loads of JavaScript libraries that do this whole model view thing. Like there's Angular, there's Ember, there's Backbone, yeah? They're all doing roughly the same thing, aren't they? So what's unique about Knockout? What kind of interesting contribution does it make to this space? And I think the unique aspects of it can be boiled down into these three things. So firstly, Knockout is a very focused library. It only deals with helping you build your user interface. So it's very small and lightweight. It's about half the size of any of the other significant MVV model view libraries. And it's designed to be integrated with any kind of data access or URL management system that you want to use. So a lot of flexibility and lightweightness there. Secondly, backward compatibility is very, very important to Knockout. Knockout has 100% support for IE6, believe it or not. So you can very safely drop Knockout into basically any web project and it's going to work okay. And we're not planning on dropping the IE6 support immediately, or any time for that matter. And thirdly, this is the most important point, and it's also the most subtle one that many people often overlook because it's not obvious what reactive means. So you kind of ignore it and you think it's like templates and stuff, and it's not. So let's think about what is this reactive pattern that Knockout encourages. And how does that differ from other ways that you might traditionally structure your code? So I will show you with code in a few seconds, but I want to show you this last slide first. Now, consider this scenario. This is just a typical example, something you might be doing in your code. You might have some set of things. I don't really care what those things are, but let's say you're keeping track of whether they're modified or not. And also, you're keeping track of whether the user is logged in or not. And you've got a save button. And you want, as a developer, to make that save button light up, become enabled, or disabled at different times, depending on the state of your model. So a traditional way you'd approach this is you'll define some kind of intermediate property, and let's call it can save, and we'll have some rule like you can save if you've modified something and you're logged in. So you'll structure that as a function or something like that. And so all of those different pieces of input are going into that function, and it's producing some output there. And then if you're using Knockout, you would probably bind that can save property onto the button there with the enabled binding. And so if it's currently false, then the button will be disabled. Now, the thing that's reactive here is that if something changes in the underlying data, like let's say something becomes modified, then Knockout knows that that's going to affect the can save property, and it will automatically reevaluate it. You don't have to tell it to do that. You don't have to set up relationships manually like you would do with most other libraries. That's just automatically interpreted by the framework there. And so that will cause the button to become enabled without you having to write any other code. Now, other libraries don't do this. They force you to declare stuff manually, or they have to reevaluate everything to see what might have changed. Knockout is able to infer the dependency graph. And so you'll start to use that for a lot of things, not just for updating your user interface, but also for managing general flows of data through your model. So let's switch over to writing a little bit of code so you can see this. So how's the font size? Can people at the back see this? Yeah? Good. Right, now, this is a 20-minute talk, so I have to base my demo on a classic situation that everyone already understands. So I'm going to do a shopping cart. And in a shopping cart, you typically have lines, and the line is something that has which product the person is buying and what quantity of it they're going to buy. So let's stick a couple of properties on here. So you see that I've got a product which has got a name and a price, and then I've got a quantity. And if you have used Knockout before, you might be familiar with this other way of defining properties, which is like this, with the ko.observable. For those of you who haven't seen it, just ignore it, because I'm not going to dwell on that in this talk. But as far as Knockout is concerned, we can just have regular properties like this. And now I want to compute something based on these two values. So the obvious thing would be to compute a subtotal. And how would I do that? Well, I'm going to tell Knockout that I want to define a property on this object called subtotal, and the value of it will be, if we've got a product selected, then it will be the price times quantity, otherwise it's 0. Okay. Now, I want to be able to show you how often this does or does not get reevaluated. So I'm going to drop in a console log message every time this evaluator gets called. Right, let's see this in the browser now. Go into the browser, I'll reload, and now I'm going to create an instance of this order line. And then I'm going to evaluate the subtotal. And you'll see that that does cause my evaluator to run, as you'd expect. If I run it again, does it have to evaluate again? No, it does not. Because Knockout knows that nothing has changed that might possibly affect the output from that function. So it's very efficient, I can call that as much as I like. But what happens if something changes? Like, let's say the user wants a lot more of these things. Now, Knockout knows that changing that quantity is going to affect the output from subtotal, so it reevaluates it. Okay, so that's kind of cool. But let's take this a little bit further. Let's say we want to chain multiple computed properties together. And as an example of that, let's say that we want to deal with taxation. Tax is a bit boring, but you know, it makes a good example. So I don't know what your local tax rate is here, but let's say it's 25%. And we want to work out a subtotal after tax. Okay, so I've got a property on this object called subtotal after tax, which is defined as subtotal times tax rate. And again, we're going to track how often that gets evaluated. Right, back in the browser, create one of these order lines again, and I'll evaluate subtotal after tax. And doing that involves evaluating subtotal, and then we get the end result. And now I can request that without having to force any recomputation. This time, let's see what happens when I change some of the underlying data. If I change the quantity, that's going to conceptually affect the subtotal, which in turn affects the subtotal after tax. And that's exactly the same as how Knockout models this internally. So we're going to force reevaluation of subtotal, which in turn forces reevaluation of subtotal after tax. Makes sense. But the clever bit is what happens if I just change the tax rate. Now, is that going to force everything to be reevaluated? No, it's not. So if I change the tax rate to some insanely high value like that, it's going to affect the subtotal after tax, but it does not affect the subtotal. Knockout is able to understand the actual dependency graph. It's not that it's got some special built-in knowledge of the idea of tax, it's just actually watching your code as it runs. So it's able to be very efficient and minimal about what stuff gets recomputed. And this basic mechanism is something that you can use to handle all kinds of different flows of data through your system. And one special case of that is updating your user interface. But you're not limited to use it just for that. Right. Let's take this example and make it a bit more interesting, because then I can show you a bunch of other cool features. Let's say that instead of just having a single order line, I want to have a series of order lines, because you generally tend to do that in a shopping cart. And just to avoid having too much code on the screen at once, I'm going to get rid of the concept of tax, like that. And in one fell swoop, I've put all the tax accountants out of a job and made everyone's life a lot easier. And next, I want to have some way of modeling a collection of these order lines. So how would you do a collection with Knockout? Well, you would do so very easily. You just define some other class and give it a property which is an array. So I've got an app view model there. That's going to act as a kind of top-level view model, and it's got an array. And notice I don't have to inherit from some special base class or anything. I'm just telling Knockout that I want to track this object. Now, let's put a bit of test data in there. I'm going to stick a couple of order lines in my app view model. At the moment, as you see, it's hard-coded to have exactly 2 order lines. I'm going to implement a proper add and remove feature in just a minute. But before we get to that, let's just start with those 2. And I want to somehow tell Knockout to display a user interface based on this data. How am I going to do that? Well, Knockout has this apply bindings function. And what I'm doing here is I'm saying, when the application starts up, I want to bind a user interface, whatever that means, to an instance of, well, currently it says order line, but that's wrong. I want to bind to an instance of app view model. Okay, now, how does this actually work, and what is a binding? What are we talking about here? Well, this is Knockout's alternative to a traditional templating system. I want to display a table which has got a row for each one of those order lines. And I can do that with just some straightforward markup. Here, I've got a straightforward HTML table with a header row. And then on the body row, you see I've got this data bind attribute. And I'm saying that I want to repeat some elements for each one of the lines in there. And this is why Knockout developers don't need a traditional templating system, because you can use bindings like for each and if and so on to get all the kind of control flow stuff that you would normally need. All right, so that's going to render a little bit of a table. But what stuff is it that we want to render for each one of the lines? Well, let's drop in a bit more markup that I've already prepared. And apologies for the crazy line wrapping. Is that font size okay? Is that too small now? That's okay? Yeah, good. All right. So as you can see, for each one of the lines, I'm going to have a table row, and I'm going to do 3 columns. In the first column, I'm going to have a drop-down list, a select box, and I'm binding the value that's been selected to the product on the corresponding order line. I'm also using other bindings like options to specify which options are going to appear there. Let's not worry about where that stuff's defined. And then in the next column, I'm going to have a numeric text entry field, and I'm binding the value on that to the quantity. And finally, I'm going to display the subtotal using this text binding to make the text on this column correspond to the subtotal on the row. So hopefully that, now if I run it in the browser and I make this go away, is going to display these 2 rows. And it does. And in fact, if I start changing the entries in here, then let's make this fit on the screen, then you'll see that the subtotal is getting updated, as you'd expect. Now, sometimes we get these crazy rounding errors. That's got nothing to do with Knockout. That's just general JavaScript arithmetic. And I'll show you a way that we can deal with that in a minute. But before we get to that, let's think about adding and removing entries here. Because in telling you this, I can show you how we can invoke functions on the view model. Now, oh, dramatic pose. Okay. Right. So in the view model, we're going to implement a little bit of logic that corresponds to adding and removing stuff. And this is going to be abstract. It's got nothing to do with HTML, and you can unit test it if you want to. So how will that work? Let's put in a little bit of code here. So you see, I've got a function called addLine, and very simply, it just grabs the list of lines and pushes a new order line into it. Couldn't be much more obvious. Remove line, that takes the array of lines and removes a line from it. And the bind this thing deals with the perennial JavaScript issues around this. But it's not strictly necessary, so if you don't know what that means, you can ignore it. Okay, so we can add and remove stuff, and that's nice, abstract, testable code. But I need to have a way of exposing this functionality to the end user. So they need a way of being able to call addLine. And I would like there to be a button in my UI. When you click it, it adds a line. Pretty straightforward. So let's do that very easily with just a bit more declarative binding. All right, then. Now, I'm using Bootstrap here, which is why I've got these crazy-looking class names, navbar inverse, navbar inner. That's Bootstrap, and it's got nothing to do with Knockout. The only thing that Knockout cares about here is that I've got a button element with a data bind attribute, and I'm saying that the clicks on this element should be associated with the addLine function on my view model. So in my browser now, if I click Add Item, it will indeed push a new entry into that array, which then triggers the appropriate refreshes, whether that's computed properties or the UI updates or whatever. Okay, that's good. Next thing, I want to be able to remove stuff. And of course, instead of just having one remove button, I need a separate remove button for each row so that the user can say what it is they want to remove. So I guess that should be a new column in my table. I'll drop that in about here. Okay, so I've got, if you can see the strangely wrapped text there, that is Bootstrap for display a trash can icon. And Knockout doesn't care about that. It just cares that when you click on this entire cell, we're going to call remove line. Now, you may think, what's this parent thing? Well, when we're inside the context of a for each, we're working on an individual line. But I didn't define remove line on a line. I defined it on the parent object, the app view model. So that's why I've got this parent qualifier here. So you can navigate up and down your view model hierarchy with these qualifiers. Right, let's see if it works, shall we? Now you'll see when I add items, they get added, and when I click the trash can, they get removed. So it works, and that's nice. And if we review the code, it's pretty hard to see how this code could be any simpler than that. I mean, it's just a handful of lines of code, and we've got the functionality we wanted. That's good. But again, let's push this forwards a little bit. Let's say that, well, firstly, let's get rid of this sort of test data nonsense. So instead of having 2 lines in there, we'll have 1, and the default quantity, we'll set that to 1 as well. Now, I would like to display a grand total, because you tend to do that on a shopping cart. It's a bit nasty to make the user do the arithmetic themselves. And a grand total is a good example of a computed property. It's pretty much the definitive example of one, in fact. So how would we do a grand total? Well, again, define a property called grand total. And my logic here is I start with 0, and then for each one of the lines, I'm going to add on the subtotal. And that's all there is to it. Now I want to display that in the user interface. So again, I can use a text binding to make that show up on any element that I want. So I'm going to put that into my, what's it called, the nav bar down at the bottom there. And so here we go. I've got a strong element, and the text is going to display the grand total. Back in my browser, you'll see I've got the grand total displayed there. Okay, but let's see if we can get a bit of a problem. Right, we've got this hideous rounding error nonsense going on. You don't want that. Clearly, you would want to round this to 2 decimal places. So how would you do the rounding? Where would that logic go? There are a few different options. One option that you can use, that's fairly straightforward in this case, is you can take advantage of the fact that Knockout allows arbitrary expressions in these binding attributes. So when we display grand total, I can put to fixed 2 on it. And that's going to round this element to this numerical value to 2 decimal places. So back in my browser now, you'll see I have indeed got 2 decimal places, and I won't have that problem anymore. Okay? But then what if I want to display a currency symbol as well? Well, I could, if I wanted to, and I don't want to, but just to show you that I could put the dollar symbol right there into the binding as part of this expression. So now back in my browser, I've got the dollar symbol there. Okay, so it works. But I'm sure some of you, as web developers, are starting to feel a bit uncomfortable with this, because now I've got this, what looks like non-trivial logic inside my view in this weird, awkward kind of hybrid way. And I would even have to duplicate that logic with the subtotal as well. And then what if the currency symbol changes? So really, I want a way of factoring out this, this rule into some kind of separate place. And this is... raises a question, doesn't it? So where does that go? Does it go in my view? No, because it's procedural logic. Does it go in my view model? Not really, because it's not application logic. It needs to go into some sort of third intermediate place, somewhere between the two of them. And Knockout has just the right extensibility point here. So we can write custom bindings. You see these bindings that I've already got? I've got options, text, click, and so on. Well, I can create my own custom binding as well. Let's say I want to create a binding called currency text that formats text as a currency. And I can do it with just a few lines of code. So the way to register a custom binding is to create an object on the Knockout binding handlers object there. And I'm saying that whenever the associated model value is updated, I want this function to be called. And I'll take care of somehow getting the value onto the DOM element. And so my logic for actually putting the value there is straightforward enough. I grab the current value, I format it as a string with the dollar symbol and the 2 decimal places. And finally, I'm using jQuery to set the text on the element to this formatted amount. Okay, so how do I actually use currency text? Well, quite straightforwardly, I can get rid of all this junk from here So we'll reduce it just back to text grand total. And instead of using text, I'll use currency text. And I can reuse it up here with the subtotal as well. So a nice bit of code reuse. And if I reload, you'll see that I've now got the correct currency formatted values showing up in all the relevant places. So custom binaries are a very commonly used extensibility point in Knockout. Now that's all I have time to talk about in this talk. So in summary, you saw how we started off by thinking about the Model-View-ViewModel pattern. We then went from there to look at how Knockout deals with reactive programming and pushing changes through different levels within your model and ultimately, optionally, into your view. Then we looked at how to use declarative bindings to update your user interface. And finally, how you can create your own custom bindings. So I could tell you a lot more stuff. I could go on for several more hours telling you interesting features, but I don't have time. So if you want to learn more, I strongly recommend you go to learn.knockoutjs.com, and that guides you through a set of interactive examples in your browser. You don't have to install anything, and it'll show you how to build much more interesting things than I had time to show you today. So I hope that was of use to you. I'm doing another session tomorrow, not about this, but about a way of building web apps and mobile apps much faster, and it uses sort of vaguely related principles. So if you're interested, come to that session tomorrow. And otherwise, I hope you have a really great rest of conference and a great rest of the day. So thank you very much.